Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Hope you are well. Today I will discuss a very important topic, mainly how to generate pan-sharpened image using intensity hue saturation fusion method. I will try to explain all of things step by step. I hope after completing this tutorial you are able to do generate the pen sharpened image using intensity hue saturation. So let's go. So first of all, you need to define a study area. In this case, suppose I want to work for a specific boundary. So let me import my study area. Okay, just I import my study area and I put it's a geometry. So after that, we are just simply define a time period. For that, just take a variable, suppose start date. I put the time, suppose year of 2024 1st January, and also take another variable in date and mention the in date, suppose year of 2024 December 31. So just to simply import my time period. After that, we just need to filter our image collection. So in this case, I want to work for Landsat. So basically Landsat Imagery, it's a 30-meter resolution, but in this case I just try to decrease the resolution in 15-meter using this method, intensity saturation. So let's go try to show you that how we can work with that. Just you can see the top of, I just choose the top of sphere, and you can see the 30-meter, but we try to apply this method, intensity hue saturation fusion method, and then we try to decrease the resolution, mainly pixel size decrease 15-meter. So let's go. So for that, just I copy this image collection and then just paste here, then give a variable name. I just put the name, suppose L8. You can put any name. After that, just we simply filter, just use here dot filter bounce function with geometry, then put the filter date. I already defined the start date and end date. Just I copy this variable and define the start date and also end date. Just I define and also filter the image metadata. Put here filter earth engine dot filter dot less than. So just put here that cloud cover. It's the image properties name. Cloud cover. I put the assign the value, suppose less than 1. Okay, just I choose it. So after creating these things, we are just check how much images we find out in here. Just use at the print and call the variable name which is stored all of things. Just use at the size function and run the code. So we find out the total 4 images. So after getting this type of 4 images, if you want, you can also create the median or also create the mean. So in this case, we compute the mean composite. Okay, basically compute the mean or average value for each pixel over the selected time period to reduce the noise and remove the cloud. Okay, so let's go try to do it. So for that, just take a variable, suppose mean image, and call the L8 and use at the mean function and then clip with our study area, which is geometry. Okay, so now if you want, you can also visualize this image. We can visualize this type of imagery, and then we also display this result. Or if you want, and before that, if you want, you can also apply the intensity, hue, saturation, mainly pan-sharpening. These things you can also apply. Just need to create a function, and then we can easily do it. So let's go try to create the function to compute the intensity, saturation, and then check it. So for that, just take a variable. Suppose I put the variable name is that pan sharpen intensity, hue, saturation. You can put any name as a variable. Put the function keyword, and then I put the element name, suppose image, and in this case just I put my argument. So in this case, my first of all my argument is that I just select that band, shortwave infrared 1, near infrared band, and blue band. Okay, and also select the pen sharpening band. So let's go try to do it. Just take a variable, suppose RGB, or if you want you can also choose the any other band, suppose near infrared band or RGB, mainly red, green, blue. So in this case I want to apply the pen sharpening technique for selective band. I choose short wave infrared 1 band. So basically just I use the image and put here the select function, select, and I apply here, just make a list, and I input here B6, meaning short wave infrared 1 band, then put here the near infrared band, and also put here that blue band. Okay, just I choose 3 band because I want to apply the intensity, hue, saturation on this 3 band. Okay, suppose you want to apply it for the red, green, and blue, then just apply the red, green, and blue. Okay, so in this case I want to apply this pen sharpening intensity, hue, saturation only for these 3 bands. So that's why I simply select these 3 bands, and now call the panchromatic band. Just take a variable, suppose pan, and I call this band, basically just select the band which is the panchromatic. Basically it's called the B8 band. It's a panchromatic, and panchromatic basically we can see this is the 15 meter. So now I want to use this band 8, panchromatic band, and I want to apply the intensity, hue, saturation for this 3 band and create the band combination. So let's go. After that we need to convert the RGB to HSV color space. So let's go try to do it. Just convert. For this conversion, just take a variable HSV, then I call the RGB which I already created, and apply here the unit scale. I just choose and put here that unit scale 0 and 1, and then just apply a function RGB to HSV. So this function is simply used to convert RGB to HSV. After that, replace the intensity with the panchromatic band. Just we need to replace it. So let's go try to do it. For that, just take a variable, suppose intensity, and then I just call the pan, which I already stored the panchromatic band, and put here that unit scale, and choose the unit scale 0, 1. After that we are just create the sharpened. Okay, so for that just take a variable, suppose sharpened, and use our ee dot image dot cat, simply connect, just make a list, and use at the SSV dot select, just we select this hue SUE, and also just use at the comma sign, and also call the SSV and select the saturation. After that, just put here intensity. And now it convert ASV to RGB. So for that, just use the function ASV to RGB. So just use this function to convert, replace. So now finally what I return from here, from this function, so just I define it. So for that, just use a function return. Just I return this sharpened, these things multiply with this value 255 and put at that byte function, convert to 8-bit format. So that's why we simply multiply 255 and also put at the byte function. So this is the function. So basically this function create the intensity hue saturation, mainly pan sharpening, and we need to use always this type of this function. Always we need to use. Suppose in this case you can see I want to apply the intensity hue saturation only for this 3 band. So just I simply use this 3 band. But when you want to apply it for others band, so for that simply change the band name, then it will be easily okay. And all time you are just use the same function. So basically this function apply the intensity hue saturation. Okay, so after creating this band, we already selected our 3 band and also selected the panchromatic. Then we just convert the SSV, mainly hue saturation value, space, and replace the intensity, mainly brightness, with the panchromatic band to improve the spatial resolution. Finally convert back to RGB color again and return a byte scale 0 to 255 and proper visualization. So for that we just find out the proper visualization. So that's why we simply return it. So after creating this pan sharpening, these things we need to apply, and then further we are just simply clip. Okay, just apply the uh, intensity hue saturation method on the mean composite. We are simply apply on the mean composite. You already create the mean composite. So let's go try to apply and then check the result. So for that, just take the new variable. Suppose I put the variable name is that you can put any name. I put the suppose sharpened image. So after that, just we call this function variable name. So this is the function variable name I simply call, and now I want to apply it on the mean image. So this is the mean image. Just I copy mean image. Just I copy and paste here. After applying that, just clip with our study area. So just use here the clip study area, mainly geometry. Just I apply the geometry. So this process we simply apply the function fusion method which I created and stored it in this function variable name. Simply connect with the mean image. So now we can simply define our visualization and further we just display our imagery. So let's go. We try to display this imagery and then check the result, what we find out in here. So let's go try to add this visualization. Just I try to add here map.add layer and then display this result. Just use our map.add layer and I want to display, suppose I want to display for, first of all I display the mean image without saturation or just without function for increasing the resolution, decreasing the resolution. Just run it and also focus in here. Map dot center object is mainly geometry. I put the suppose 10 and click run. So now it display one image. We find out that, so basically it is the normal image which we find out normally. So this imagery we find out in here, and further I just add the band combination. Suppose I put here the B6, then put here the B5, and also put at the B2, and also increasing the stressing 98% to look more better result. Just apply and also import. So now it create this type of image visualization. Basically it is that not apply any kinds of intensity hue saturation without it. So just I put here, it's a image 30 meter, okay, 30 meter resolution. So now these things I want to display and show the result. So for that, just use the same line of code, just simply change the variable, it's more better. Just I paste, and this simply copy this variable and paste here, and I put it, okay, I add the letter, and it's a 15-meter resolution. Okay, just I put at the 15, I put the layer name. So now it create another layer. Okay, so just I add the band combination. So I use the same, suppose just use automatically select in here, because you can see I apply this B6, B5 and B2, so automatically it's selected. So just I stressing it and apply and also import it. So just copy and then paste after this object name. So now finally find out this imagery. So now if we just compare this imagery, so first one is for we find out the 30 meter, but when you just increase the decrease the resolution, mainly decrease the pixel size, then we find out the more good resolution. Here you can see, so this is that 15 meter. Okay, so in the 15-meter resolution we can easily identify all of buildings, all of things we can easily identify. But you can see this is the 30 meter. Okay, this is the 15 meter, this is 13 meter. So you can see the difference between these things. So you can also get the suppose just more zoom, then it will look more better. So here you can see this is the result. So this is the result for 15 meter. So this is the result 15 meter. We find out this type of imagery. When I apply it for 30 meter, you can see. Okay, so you can see. So 15-meter resolution is more clear. It look more better. Okay, 15-meter is look more better. And when you are using the 15-meter, then we can easily classify it. So this is the way how we can easily apply the different types of band and also create the decrease the resolution. Okay, so you can see find out the 15-meter resolution and the 30-meter. Further you can also export this type of imagery and also work with the different types of work. So basically this is the process to work with the intensity hue saturation fusion method. So in this case you can see here just I apply it for this band. If you want you can also change the band combination. Suppose I need it for two color composite, mainly red, green and blue band, just apply the red, green and blue, or any other three band combination, just apply, then we can easily apply. Or if you want you can also need the more band, so you can also do it easily. So I think three band is also more better. So just apply the three band, suppose RGB, red, green and blue, or any other band combination, just apply in here, then we can easily get this type of things. So this one is 30 meter, this one is for the 15 meter. So further we can easily get the more better imagery, because 30-meter resolution is not look more better, but when we find out the 15 meter, then we can easily identify all of feature easily. We can easily identify all of feature. So I hope this tutorial is also help you for the different types of your work to get the satellite imagery from Google Earth Engine. So in the meantime, I also give you an announcement for our upcoming online training program. So basically this class will be start from 21st March, and now this resolution is the open. So basically in this online training program, we try to focus on beginners who don't have any knowledge on the Google Earth Engine or Python or JavaScript programming. So after completing this online training program, you are able to do any types of remote sensing analysis using the Google Earth Engine. So this class will be start from the 21st March. Now this registration is open, and you can check all of details from this website. So I already added this website link in the video description. So you can check all of course content, all of details for our upcoming online training program, and you also get some benefit after completing your all of assignment. You can get the course e-certificate, you can get all of materials, mainly slide, PDF, or practice code, or recorded session. You also get the lifetime teaching support. Basically, after completing this full online training program, when you face any problem regarding any issue, you can also get the freely support regarding this online training program, as well as you also get the research collaboration opportunity regarding this any topic. If you are interested to publish the research paper, both combination, then it also possible. Then you also get the support. So if you want to join this online training program for our upcoming batch on 21st March, then simply contact in our WhatsApp number. You can also contact in our email for book your seat. So don't waste your time. Let's jump and start the registration, and also get the 50% discount, because first 10 days will get the 50% discount on this online training program. So today's number. Thank you for asking that. Stay happy, stay safe.